This is 2.2, the constant multiple rule. So in this section, we're going to start to build more of our derivative rules as we define functions with function equations. So this first rule is the power rule, and we saw this start to develop in the last section as we were dealing with the definition of the derivative. In the power rule, a power function is x with a constant exponent. So this n value right here is a constant. So I'll say constant exponent. So examples of power rule eligible equations are x squared, x cubed, x to the fifth, x to the negative 10th, even x to the 2/3 when we have fraction exponents. Those are all eligible to be derivatized, if you will, with the power rule. And all we do is we take that exponent that we had up here, so this n, and we move it to the front. So it becomes that coefficient right there. And then we take the exponent and we subtract 1 from it. So when we try this with x to the 4th, to find f prime of x, I'm going to bring the 4 down in front. So I'm going to say 4x, and then I'm going to take my exponent and subtract 1. So 4 minus 1. So f prime of x is going to be 4x cubed. And that's all there is to it. So when I do the next one, I'm going to take g prime of x equals, the 5 is going to move down to the front. So we're going to have 5x to the 5 minus 1. And so g prime of x is going to be 5x to the 4th. Okay, so when your exponent is positive like that, the derivative's exponent is always going to be 1 less because of that n minus 1. I can do this with fraction exponents. So I'm going to say h prime of x equals, I'm going to move the 1/2 to the front. Then I'm going to take x to the 1/2 minus 1, so subtract 1 from my exponent. That's going to give me 1/2 x to the negative 1/2. And typically, we don't leave negative exponents, so I'm going to have you guys change those. So we're going to make this h prime of x. And when you have a negative exponent, let me write this off to the side, x to the negative 1/2, what we want to do is move that from the top to the bottom. So what I'm going to do is I'm going to take this and multiply it by x to the 1/2 over x to the 1/2. So I'm multiplying by essentially 1 and just making it look a little bit different. X to the 1/2 times x to the negative 1/2 times x to the 1/2. When you add those exponents together, so you get x to the negative 1/2 plus 1/2. In the bottom, you get x to the 1/2. Those exponents become x to the 0. Bottom stays the same, x to the 1/2. X to the 0 is 1. And you've got x to the 1/2 in the bottom. So this is going to become x to the 1/2 times 1 over x to the 1/2, which becomes 1 over 2x to the 1/2. Okay, and we'll keep practicing that because I know that's not something that gets covered in detail before you guys get to calculus. So next one, we've got a negative exponent. So I'm going to say y prime. I could say dy dx if I wanted to, but I'll say y prime. This is going to be negative 2/3. So bring that negative 2/3 down. X to the negative 2/3 minus 1. So we're going to say y prime equals negative 2/3 x to the negative 2/3 minus negative 2/3 minus 1 is negative 5/3. And the shortcut for remembering what to do with that negative exponent is all you're going to do is take the exponent and whatever it's attached to and just move it to the bottom. So I've got a negative 2/3. The negative 2 stays up top. The 3 stays in the bottom. And the x to the 5/3 moves down to the bottom and becomes positive. Next example also has an exponent because I know it's important to cover a lot of those. So we're going to do, let's do dy dx this time, just to change it up. Okay, again, y prime and dy dx tend to be a little interchangeable, so whatever you prefer. So we're going to do 5/4 x to the 5/4 minus 1 plus 2x to the 2 minus 1. So we can just do this on both terms. So that's going to give us 5/4 x to the 1/4 plus 2x. And it's technically 1, so we don't have to write it. So there's our derivative. For the next one, we talked about this a bit at the end of last unit, but this is a constant. So with constants, if we try and apply the power rule, we could say x to the 0 if we wanted to, because that is what's going on there, okay? But instead of doing that, because that gets a little icky, we can just remember y prime equals 0. So derivative of a constant is 0. So I'll write that here. Derivative of a constant always equals 0. All right, so next one. With this one, we've got a quotient, but we don't know how to do the quotient rule yet with functions that are defined. So let's try this with the power rule. So what I'm going to do is I'm going to rewrite y. I'm not taking the derivative yet. I'm going to rewrite y, and I'm going to split it up so that each piece of the numerator gets divided by the denominator. If I do that, I get x cubed plus x minus x. Whoops. Minus 1, because x divided by x is 1. So all I'm doing is subtracting the exponents. So all of those exponents in the bottom are x to the first. 4 minus 1 is 3. 2 minus 1 is 1. And then x over x, they cancel out, and you just get 1. Now I can say dy dx, let's try this without writing all the extra stuff in there, is going to be 3x squared. Derivative of x, this is x to the first. So the 1 gets brought down, so that's 1 x to the 0. And then derivative of a constant is 0. So that's going to give us 3x squared. X to the 0 is 1, so it's just going to be plus 1, and the 0 doesn't need to get written. When we have roots in calculus, they're not very useful to us, so what we do is we change the root. So before I take my derivative, I'm going to go ahead and I'm going to rewrite this. The root is 2 in this first example, and so all of these, when I have a root is here, and then I've got x to a power is going to turn into x to the power, whatever that number is, over root. Okay, so that's a couple years out, so let's review it a little bit. So the first one, the power is 3, the root is 2, so it becomes x to the 3/2. Minus, for the second one, the power is 4, the root is 3, so it becomes x to the 4/3. Now I'm going to take the derivative, and a lot of people forget to do this because they're excited that they rewrote it, and they forget that they still have to take the derivative. So that's going to give me 3/2 x to the 1/2, because 3/2 minus 2/2 is 1/2. Then we're going to do minus 4/3, and we're going to have x to the 4/3 minus 3/3 is 1/3. And there's my derivative. We can do all of these rules if we also have a coefficient in front. And this is what's called the constant multiple rule. So the constant multiple rule is the same as what we've been doing. We have an x to the n, and we have the nx to the n minus 1. We just have a constant in front. Okay, we could do this with the product rule, but remember the derivative of 3, as in the first example, is just going to be 0, so part of our product rule is going away. Okay, so let's apply this using the constant multiple rule. So we're going to say f prime of x equals, the 3 stays, and then I'm going to do 2x to the first. 3 times 2 is 6, so this becomes 6x. Same thing with the next one. We're going to say g prime of x equals, I'm going to do 4, then the 5x to the fourth, using the power rule. And then the derivative of 7x, I'm going to say 7, and then x, 1x to the 0. And when I polish this off, I'm going to get 20x to the fourth minus 7 times 1, which is just going to be 7. Next example, we've got a root, so we're going to rewrite this as 2x to the 1/2, because the power is 1, the root is 2. So h prime of x, I'm going to leave the 2, bring the 1/2 down, reduce my exponent by 1, so 1/2 minus 1 is negative 1/2. So that's going to give me 2 times 1/2 is 1, so I'm going to have x to the negative 1/2. And then just like we did on the page before, I'm going to fix that negative exponent. I'm just going to move the x and the 1/2 down to the bottom, leaving a 1 up top. Okay. Next example, we're going to have to do a little rewrite because we've got a root. So this is going to become 3x to the power over root, so 2/3, minus 4. I'm going to say y prime equals 3, bring down the 2/3. 2/3 minus 1 is negative 1/3. And then the derivative of a constant is 0. 3 times 2/3 is 2, so we've got 2x to the negative 1/3. And then I'm going to fix that negative exponent. The 2 stays in the top because it doesn't have a negative exponent. The x goes into the bottom with a now positive exponent. For the next one, I'm going to do a little rewrite so that it doesn't look like a fraction. And I'm going to make this 4/5 x squared. So then I'm going to say y prime equals, the 4/5 stays in front. Then I have 2x to the first. 4/5 times 2 is 8/5, and the x stays attached. For the next one, I'm going to have to do quite a bit of rewriting. So what I'm going to do is I'm going to go ahead and say this is 1/2 x to the 1/4. I don't have a power rule when the power is in the bottom. All of the powers that I've been doing, the power is in the top. So I'm going to actually do a rewrite here similar to what we've been doing. So we've been, if you look in the 2 examples right above this, we've been taking the negative exponent, moving it to the bottom and making it positive. I'm going to go in the opposite direction. So I'm going to make this 1/2 x to the negative 1/4. So then dy dx is going to be 1/2. I'm going to bring down the -1/4, and that's going to be x to the, and then -1/4 minus 4/4 is -5/4. I'm going to multiply my fractions in front, so that's going to be -1/8 x to the -5/4. And then I'm going to go ahead and I'm going to leave the 1 in the top, the 8 in the bottom. I'm going to move that x with its exponent down to the bottom with a positive exponent. For the next example, we would typically use product rule because it's 3x times some stuff with x in it. But we'll talk about that more later. We're going to use just the constant multiple rule, but with a little bit of a rewrite. I'm going to distribute the 3x. So I'm going to make my function y equals 18x squared minus 15x cubed. So then dy dx is going to be 18 times 2x to the first minus 15 times 3x squared. So that's going to be 36x minus 45x squared. Next example looks very similar to one of the ones on the previous page. I'm going to do a rewrite. So I'm going to say f of x is equal to x cubed over x squared minus 3x squared over x squared plus 4 over x squared. So that means now I have x, because 3 minus 2 is 1, minus 3, because the x squareds cancel. And then that x in the bottom can't stay in the bottom for constant multiple rule, so I'm going to move it up and make it -2 as an exponent. So then we're going to do f prime of x equals, this is x to the first, so this is just like 1x to the 0. The derivative of a constant is 0. And then we're going to do plus 4 times -2 x to the -3. So we've got 1, the 0 can go away. 4 times 2, that's going to get me -8 x to the -3, which gets me 1 minus 8 over x cubed. We've got a couple more on the next page. So for these two, we're going to do a rewrite. We're going to make this x to the -2 plus x to the -3. Then we're going to say y prime equals -2x to the -3 plus -3x to the -4. And then turn this into -2 over x cubed minus 3 over x to the 4th. And it's important to remember the 2 and the 3 don't have the exponent, so they stay in the top. All right, and then the last one that has a little bit of everything, I'm going to rewrite. So I'm going to say y equals, I'm going to make this 2 over x to the 1/3 minus 3 over x squared. Then I'm going to go ahead and I'm going to move those x's to the top. So 2x to the -1/3 minus 3x to the -2. And then I'm going to take the derivative. So y prime is going to be 2 times -1/3 x to the negative 4/3. Then we're going to say minus 3 times negative 2 x to the negative 3. And then we're going to clean things up. So we're going to have negative 2/3 x to the negative 4/3. And then we're going to have plus 6 x to the negative 3. So we cleaned up the coefficients. Now we're going to clean up the exponents. So we're going to have negative 2 over 3x to the 4/3 plus 6 over x to the 3rd. So all of this leads us to being able to find slopes and equations of lines. So what we're going to do is we're going to take the rules that we know and we're going to find slopes and equations of lines using derivatives. So to find a slope, the first thing you need is a derivative because slope is derivative. So I'm going to start by finding f prime of x. Using our constant multiple rule, I'm going to get 6x squared. Then to find the slope at x equals -1, I'm going to find f prime of -1. Since I have a function definition of my derivative, I'm going to go ahead and just plug in -1 and end up with 6 times 1, which is 6. So this is my slope. It's my derivative, but it's also my slope. Same thing with the next function. With the next function, I see that I have a root. So I'm going to go ahead and I'm going to rewrite that as x to the 1/2. And then if I want a slope, it says find the slope. Slope says take a derivative. So I'm going to say g prime of x equals -4 times 1/2 is -2, x to the -1/2, which I'm going to rewrite as -2 over x to the 1/2. Then I'm going to find g prime of 4 because it told me to find the slope at x equals 4. I was given an at. So I'm going to do -2 over 4 to the 1/2. 4 to the 1/2 is square root of 4, which is 2. So this is going to be -2 over 2, which gets me -1. And that's the slope. Let's try the same thing for the next couple of examples. So for h prime of x, I've got multiple terms here, so I'm just going to go down the line. The derivative of 3x squared is 6x. The derivative of -7x is -7. And the derivative of 2 is 0. To find h prime at -4, because it did tell me at -4, I'm going to plug in -4. So we're going to do 6 times -4 minus 7. I'm going to ignore the 0 because it's not going to impact my answer. So we've got -24 minus 7, which is -31. And that is the slope. Okay. More specifically, we could even say this is the slope of h of x at x equals -4. If I change that x value, if I make the x value 0 or -10 or 3, it's of course going to change the slope on the function. All right, so the next one, we definitely have to do a little reworking because it's a product right now. So I'm going to go ahead and I'm going to rework that. And if you're a box person, let me do a box. Just to review, expanding these. So I'm going to have 2x plus 3 and x minus 1. If you're a FOIL person, you can do this with FOIL. Let me put that minus in front of the 1. So 2x times x is 2x squared. 3 times x is 3x. 2x times minus 1 is minus 2x. And 3 times -1 is -3. So I'm going to have 2x squared. The diagonal of that box are going to be like terms. They're going to combine and give me plus x and then minus 3. So then I'm going to go ahead and I'm going to take the derivative. So I'm going to say y prime equals, and I'm going to get 4x plus 1 minus or plus 0. When you don't have a value to plug in, you can either do the parentheses, or what you'll also see is you'll see a straight line with what you're plugging in attached to the bottom of it. And that straight line just means such that. So this just reads y prime such that x equals 0. So I'm going to do 4 times 0 plus 1, which gets me 1. And that's the slope of y at x equals 0. Okay. So slope leads us to tangent lines. Because if we have the slope, we can write the equation of a line. What we're going to use in this class is a version of a line that is not as commonly used anymore. Sometimes Algebra 1 teachers teach this. You're used to seeing y equals mx plus b. We're going to use what's called point slope form, and this is point slope form. Okay, it's just another version of the equation of a line. The y1 and the x1 are your specific points. So this is the point x1, y1. Okay. All right, so we want to find the equation of a tangent line to f of x at x equals 0. So tangent is another buzzword. Tangent means derivative. Take the derivative. So I'm going to find f prime of x, which is going to be 6x squared minus 6x plus 0. I'm not going to bother writing it. Then I'm going to find f prime of 1 because it told me to find the equation of the tangent line at 1. So I'm going to say 6 times 1 squared minus 6 times 1, which gets me, let's see, 6 minus 6 is 0. Okay, so this is my slope. I've got an x value. I need 3 things to write an equation of a tangent line using point slope form. I need the x, I need the y, and I need the slope. I have the x. I don't have the y. So to find y, I'm going to go ahead and find f of 1. So I'm going to do 2 times 1 cubed minus 3 times 1 squared minus 5, which is going to get me, let's see, 2 minus 3 is negative 1, minus 5 is negative 6. So this is your y value. So then I'm going to write my point slope. So I'm going to say y minus my y value equals my slope times x minus my x value. Okay, so if we have to kind of highlight these, this is this guy. The 0 is the slope, and the 1 is the x value. That's where all that came from. And then we clean this up. We make this y plus 6 equals 0, because everything goes away on the right-hand side. So if you wanted to, you could say y equals negative 6. Okay, let's try this with another example. So I see g of x. I'm going to go ahead and rewrite it as x to the 1/3. And I know I need 3 things. I'm going to kind of make this a list. I need an x, a y, and a slope. So I see the x. I see that x is equal to 27. I need a y value. So I'm going to go ahead and find the y value. So I'm going to say g of 27 equals 27 to the 1/3. The cube root of 27 is 3. So there's my y value. Then I need a slope. So I'm going to say g prime of x, and I'm going to take the derivative, which is 1/3 x to the, let's see, 1/3 minus 1 is 1/3 minus 3/3, so that's negative 2/3. I'm going to rewrite that. I'm going to make it 1/3 x to the 2/3 so that I can evaluate it. I'm going to say g prime of 27 equals 1/3 27 to the 2/3. Okay. When you evaluate fraction exponents like this, I like to start with the root first, so the bottom number. So I'm going to say, let me write it over here in red, start with 27 under a cube root first. So 27 under a cube root is 3. Then 3 squared, which is 9. So that gives me 1/3 times 9, or 1/27. So I've got all my pieces now because I've got my slope, I've got my y value, so this is y, this is slope. Now I can put them all together, and I can say y minus my y value equals my slope, 1/27, times x minus my x value, which is 27. Okay. Let's try another one. So find the equation of the line tangent to h of x equals 4x times x minus 5 when x equals 0. So I'm going to rewrite my h because I've got a product right now. So I'm going to distribute that 4x. So 4x squared minus 20x. I'm going to find my y by doing h of 0. So 4 times 0 squared minus 20 times 0 gets me 0. So that's my y value. Then I'm going to find my derivative. So I'm going to say h prime of x equals 8x minus 20. I'm going to plug in my x value, so 0, and get 8 times 0 minus 20, and get negative 20, and that's my slope. So I've got all my pieces. I'm going to put them in place. I'm going to say y minus my y value, which was 0, equal to my slope, negative 20, times x minus my x value, which was 0. So I have y equals negative 20x. Okay. Next example. We've got an interesting function that needs to be rewritten. So y equals, I'm going to rewrite this as x to the negative 1/2 plus 2x to the negative 1/3. So I'm kind of doing 2 steps at once there. So turning that into x to the 1/2 and then bringing it up. And then the second one, turning that into x to the 1/3, bringing it up to the numerator. I'm going to go ahead and find the y value when x equals 64. So I'm going to do 64 to the negative 1/2 plus 2 times 64 to the negative 1/3. All right, so let's think about this. Whoops, I forgot. Oh yeah, I'm good. So the square root of 64 is 8. So this is going to be 1/8. And then we've got 2 times the cube root of 64 is 4. So this is going to be 1/4. So we've got 1/8 plus 1/2. And that's going to be 5/8. And that's our y value. Okay. If stuff like that hurts your brain a little bit, let the calculator help you. Okay. If it hurts your brain a little bit, let the calculator help you. So then I'm going to take the derivative. I'm going to get negative 1/2 x to the negative 3/2 plus 2 times negative 1/3, so negative 2/3 x to the negative 4/3. So then we're going to say y prime equals negative 1/2, and we're going to plug in, whoops, I forgot, x equals 64. So we're going to do x to the negative, I need to plug in the 64. So we're going to do 64 to the negative 3/2 minus 2/3, 64 to the negative 4/3. Okay, that's our slope. I'm going to show you a trick because remember we have the AP stop. You have a stop point for the AP exam. So what I can do here is I can say y minus 5/8 equals my slope. Let me put a big bracket around it. So we're going to say negative 1/2, 64 to the negative 3/2 minus 2/3, 64 to the negative 4/3. So there's my slope. And then x minus 64. That is, if I clean up the 64, a legal answer. Okay, I could have even gone back up here to my y value that I was working on, one of these steps, and used that instead. Okay, it's a legal stop. Okay? Of course, it's always nice to stretch your brain a little bit. All right, last two, use a graph. So we're going to find the equation of the line tangent to y equals x squared minus 4 at the point 1 comma negative 3. So we're looking at, on this graph, 1 down 1, 2, 3. So we're looking at that point, and the tangent line is going to look like that. So what we've been doing, we've got an x value, we've got a y value, so we don't have to find those. We just need a derivative. So y prime is 2x. Y prime at x equals 1, because that's our x value, is 2 times 1, or 2, and that's our slope. So we're just going to say y minus our y value, which is negative 3, equal to our slope times x minus our x value. Okay. And for this last one, we've got the point 1, 1. If we sketch in a slope, it looks like that. We've got our x value. We've got our y value. Now we just need a derivative. So we're going to say y prime of x equals, that says negative 1/2 in the exponent. So we're going to have negative 1/2 x to the negative 3/2. We're going to say y prime equals negative 1 over 2x to the 3/2. And we're going to plug in 1. So y prime at x equals 1. And get negative 1 over 2 times 1 to the 3/2, which is going to give us negative 1/2. And so we've got all our pieces. We're going to say y minus 1 equals negative 1/2 times x minus 1.